Hello, welcome to Chapter 3.5, Part 2, Substitution. In this example 1, we're going to solve the system of equations using substitution. In this case, unlike graphing, we're going to find an exact solution. So let us go over to the whiteboard and work this out.
Example number 1 here, we have y is equal to 4x, and we have x plus 3y is equal to negative 39. Now the thing is we have this isolated here. So what we're going to do is where we see the y, we're going to put in 4x. So we have x plus 3, and there's the y, but y is also equal to 4x. So I'll put 4x here is equal to negative 39. Now, I only have one variable and everything is in terms of one variable. So now I can just perform a regular algebraic solution, solve this in a regular algebraic way. So I have x plus 12x is equal to negative 39. So now I have 13x is equal to negative 39. And that means that x, I divide each side by 13, and that means x is negative 3. But I'm not finished yet because remember, I have to find a coordinate because I'm looking for where they intersect. So I'm looking for a point. I'm looking for an x and a y. So now what I'm going to do, now that I know what x is, and we have the equation y is equal to 4 times x, but we know x is negative 3. So now and that gives us negative 12. So it turns out that our coordinate is x negative 3 and y negative 12. So this is the coordinate where these two lines, line 1 and line 2, intersect. Now, of course, you always want to check this to make absolutely sure that it coincides. So we check. So is y, well, y is negative 12 and is equal to 4 times negative 3. So that's equal to negative 12. So that's good. And then we check the other one, and we have x is negative 3 plus 3y is negative 12, and that question mark is equal to 39. So we're just checking that, and we find that this is negative 3 minus 36 is equal to negative 39, question mark. And indeed, negative 39 is equal to negative 39. So indeed, this is correct also. So this is the point where the two lines intersect each other.
Reviewing what I just did on the whiteboard, since y is already isolated in the first equation, we're going to substitute the value of y for y in the second equation. That's what substitution means. And here we have 4x, and we're going to substitute that into y, so we get the equation x plus 3 times 4x is equal to negative 39. The result is one equation with one variable. Notice we only now have to solve for x. After solving for x, solve for y by substituting the value for x in any equation that contains the two variables, either in here or here, so let us do that. and here 13x is equal to negative 39. That means we have x is equal to negative 3. And in order to find y, we're going to take this x and substitute it into one of these two equations. I will use the first equation, y is equal to 4x, and I will substitute in the negative 3 that I found here into the x, and I finally get y is equal to negative 12, since 4 times negative 3 is negative 12. And we write the solution as an ordered pair because this represents where the two lines intersect. These are linear equations, and they intersect at point negative 3, 12. Now, it's always a good idea to check the solution of both equations. So I do this. I found that indeed that the coordinate or point that they intersect is correct. So the solution is negative 3, negative 12. And this is the point which these two lines intersect. In example number 2, we're asked to solve this system of equations using substitution. So let us go over to the whiteboard and work this one out.
In example number 2, we're given two equations. X minus 3y is equal to negative 5, and 2x plus 7y is equal to 16. Now, in order to do the substitution, we have to solve for one of the variables. So in this case, it looks like it's easiest to solve for x in terms of y. So we'll say this is equal to, x is equal to, when we bring over the negative 3y to be positive, 3y minus 5. So wherever we see an x in this equation, we put this as x. So now we have 2 times 3y minus 5 plus 7y is equal to 16. Now we distribute, and we get 6y minus 10 plus 7y is equal to 16. Now we combine to get 13y minus 10 is equal to 16. And then plus 10 plus 10. And we have 13y is equal to 26. So that means y is equal to 2. So the y coordinate is 2, but we're not finished because we still have to find the x coordinate. So we can take the first equation and substitute in y and solve for x. So here we have x minus 3 times 2, because now we have the y is equal to negative 5. And then we have x minus 6 is equal to negative 5, and then plus 6 plus 6, and that means x is equal to 1. So our coordinate, the x is 1 and the y is 2, and then of course we should check, and I'll show you the check on the PowerPoint.
In reviewing what we just did on the whiteboard, if a variable is not already isolated, solve for one variable in one of the equations. Choose to solve for a variable with a coefficient of 1 if possible. So here we have this x has a coefficient of 1, and so I moved the negative 3y over here to get positive 3y minus 5. And then I have the other equation, which I'm going to use the 3y minus 5. that is equal to x, and I'm going to substitute that in here. So I end up with this equation, and now I can just solve for y. And that's what I do. And I find that y is equal to 2. Then I take this y is equal to 2, and I substitute it into one of the two equations. So here are my two original equations, and I'm going to substitute it into the first equation in order to find x. So I find that x is equal to 1. So now I have the coordinate 1, 2. This is the point where the two lines intersect. And of course, we want to check to make sure that our solution is correct. So I check the solution in both the equations, and there I go about doing it, substituting in 1, 2, 1 for x, 2 for y, and I find that the first equation I get -5 is equal to -5, and that's correct. And then when I substitute in 1 for x and 2 for y in the second equation, I get 16 is equal to 16, and that is correct too. A word about substitution. Substitution is a good method to use if one variable in one of the equations is already isolated or has a coefficient of 1. Substitution can be used for systems of 2 or 3 equations, but many prefer other methods for 3-equation systems. The goal in substitution is to combine the two equations so that there is just one equation with one variable. Thank you very much. I hope that you enjoyed this video. Take care, be well, and goodbye for now.